I'm excited to share with you today at Conf42 Platform Engineering 2024 as we discuss enhancing cloud computing security, multi-layer protection, and advanced threat detection. As organizations increasingly rely on cloud technologies, ensuring robust security has never been more critical. Today, I'll guide you through the key strategies and technologies that can help protect your cloud environments. Let's start by looking at what we'll cover in this presentation. First, we'll start with an introduction to cloud computing and security, where we will set the stage by discussing the fundamentals of cloud computing and why security is so crucial in this environment. We'll dive into the cloud computing security challenges that organizations face today, exploring the various risks and vulnerabilities that are inherent in cloud environments. Following that, we'll move on to a multi-layer protection approach, where I'll explain how implementing security at various levels within cloud can help mitigate these challenges. Then we'll discuss advanced threat detection techniques, focusing on the tools and technologies that can identify and neutralize threats before they can cause any harm. After that, we'll look at proactive measures you can take to reduce breach times, helping to minimize the impact of any security incidents. To ground our discussion in real-world application, we'll review some case studies as well. Finally, we'll conclude by summarizing the key takeaways and exploring future trends in cloud security, which will provide insights into how the security landscape is going to evolve and what organizations can do to stay ahead. Before we dive deeper, let's take a closer look at the security landscape of cloud computing, an integral part of how organizations operate today, and its growth is nothing remarkable. First, cloud computing is rapidly growing, with spending expected to reach a staggering $1.3 trillion by 2025. This growth reflects how essential cloud services have become for businesses of all sizes, enabling them to scale, innovate, and operate more efficiently. However, as more organizations migrate to the cloud, securing these environments is becoming a critical challenge. Unlike traditional IT infrastructure, cloud environments are dynamic and distributed, which introduces unique security complexities. Cloud computing has revolutionized the way organizations manage and store data. Instead of relying on on-premise servers, companies can now leverage the flexibility and scalability of the cloud to store vast amounts of data and access it from anywhere in the world. This revolution in data management has led to significant advancements in how businesses operate, making them more agile and responsive. But with these advancements come new challenges. The dynamic nature of cloud environments means that security measures must constantly evolve to keep up with the new threats. Traditional security models are often not enough to protect cloud resources, requiring a more sophisticated, multi-layered approach. This bar chart illustrates the increasing rate of cloud adoption from 2018 to 2023. The adoption rate shows a steady growth, emphasizing the rising importance of cloud services and consequently cloud security. The rapid growth in cloud adoption highlights the need for robust cloud security measures as more organizations rely on cloud services. Given this trend, let's discuss why security is so crucial in cloud computing. As businesses increasingly rely on cloud services, the potential for data breaches, unauthorized access, and other security incidents grow. Protecting sensitive information, ensuring compliance with regulatory requirements, and maintaining trust with customers are just a few reasons why robust cloud security measures are essential. By implementing comprehensive security strategies, organizations can mitigate risks and protect their assets in the cloud. Now let's explore some of the specific challenges that cloud security presents. The range of security challenges that organizations must address to protect their data and maintain trust with customers. As cloud environments grow in complexity, these challenges become more pronounced and require innovative solutions. These include the risk of data breaches, insecure APIs, insider threats, compliance and legal issues, and a lack of visibility. Addressing these challenges effectively requires a multi-layer approach to security. Let's delve into what that involves. Multi-layer protection in cloud computing involves implementing security measures at various levels within the cloud environment. This approach ensures that even if one layer is compromised, others remain intact to protect the system. This importance of a multi-layered security strategy lies in its ability to address diverse threats and vulnerabilities, providing a robust defense against potential attacks. We will look at what are the different layers of protection are, and also how data flows through these different security layers in a cloud environment. This diagram illustrates the multi-layered protection approach in cloud security, which involves implementing security measures across various levels of the cloud environment. Each layer serves a specific purpose, from network security at the base to identify and access management at the top. This ensures comprehensive protection against a wide array of threats. By integrating multiple layers of security, organizations can create a comprehensive framework that's difficult for attackers to penetrate. Each layer reinforces the others, providing a strong defensive mechanism against a wide array of cyber threats. This flowchart represents how data moves through different security layers in a cloud environment. This includes network security, application security, data encryption, IAM, and endpoint security. Each layer of security plays a critical role in protecting data as it moves through the cloud infrastructure, ensuring comprehensive coverage against threats. Let's now move on to the step-by-step implementation of multi-layered security. Multi-layered security approach is essential for ensuring that each layer of your cloud environment is protected, providing comprehensive defense against a wide array of threats. We begin by securing the network infrastructure. This includes implementing firewalls to filter traffic, deploying intrusion and detection and prevention system, which monitors and blocks malicious activities and ensures that secure network protocols are in place. Security serves as first line of defense, preventing unauthorized access and safeguarding the communication channels within your cloud environment. Once the network is secure, the next step is to focus on application level security. This involves implementing secure coding practices to reduce vulnerabilities during the development process, conducting regular vulnerability assessments to identify address and potential weaknesses, and managing patches to keep all applications up to date within the latest security fixes. Application security ensures that the software running in your environment is resilient to attacks. Next, we need to protect the data. Data needs to be protected at when it is stored and also when it is transmitted. Encrypting sensitive data using strong up-to-date encryption algorithms ensures that even if an attacker gains access to the data, they won't be able to read or use it without the encryption key. Encryption acts as a vital safeguard against data breaches and loss. Next, managing who has access to the cloud resources is a critical aspect of security. Deploying IAM solutions to control and monitoring access, ensuring that only authorized users can reach sensitive data and systems, implementing role-based access controls, which limits permissions according to the user's roles and uses multi-factor authentication, adds an additional layer of security. IAM helps prevent unauthorized access and ensures that users only have access to the data they need. Finally, we secure all endpoints that connect to the cloud environment. This includes mobile devices, laptops, and all servers. Deploying antivirus software and endpoint detection and response solutions to monitor and protect these devices from malware and other threats. Endpoint security is the last line of defense, protecting the devices that interact with your cloud resources. Next, we'll discuss some common pitfalls to avoid when implementing these measures. The common pitfalls include overlooking endpoint security, inadequate employee training, and not regularly updating security protocols. These oversights can create vulnerabilities in your security frameworks. To effectively implement multi-layer protection, organizations should follow best practices such as regular security assessments, employee training, and the use of advanced security tools. Continuous monitoring and updating of security protocols are also crucial in adapting to evolving threats. Collaboration with cloud service providers to understand shared responsibility models is essential to ensure that security measures are aligned and effective. Next, encryption plays a vital role in cloud security. So let's explore some techniques used in cloud environment. This is a fundamental aspect of cloud security, which ensures that data is protected both at rest and in transit. By converting data into a secure format, which is unremovable without the correct decryption key. Common encryption techniques in cloud security include asymmetric encryption or encryption, encryption, homomorphic encryption. Each technique has its strength, and the choice depends on the specific security needs and the type of data being protected. Let's look at how these encryption techniques are utilized in practice with a focus on the most commonly used ones. This pie chart shows the distribution of encryption techniques used in cloud environments, with AES-256 leading its usage. The popularity of it indicates its effectiveness and reliability in securing data, making it a preferred choice in cloud security. We also have TLS and RSA used apart from AES-256. Encryption is crucial, but advanced threat requires more sophisticated detection methods. Let's now explore the stages of an advanced persistent threat. The chart here shows the stages of an advanced persistence threat, from initial reconnaissance to the completion of the mission. Understanding these stages is crucial for implementing timely and effective threat detection and responsive strategies. Early detection is key to mitigating the impact of these sophisticated threats. To address these threats, organizations need advanced threat detection technologies. Let's discuss some of these technologies next. Advanced threats in cloud computing are sophisticated attacks that often bypass traditional security measures. These threats may include advanced persistence threats, zero-day exploits, and targeted attacks. To combat these, organizations need to deploy state-of-the-art technologies that can detect and respond to malicious activities in real time. Technologies such as intrusion detection systems, behavioral analytics, machine learning algorithms, and threat intelligence platforms are essential. Several case studies highlight the effectiveness of these technologies in real-world scenarios. Now let's move on to the importance of regular security updates and audits in maintaining cloud security. Regular security updates and audits are essential components of a comprehensive cloud security strategy. By keeping security systems up to date and conducting thorough audits, organizations can identify vulnerabilities, ensure compliance, and mitigate risks before they are exploited. Automated update mechanisms and patch management systems are critical to this process, which ensures consistency and prominence across all systems. Let's visualize the impact of regular updates and audits on reducing vulnerabilities that with a comparison chart. This bar chart compares the number of vulnerabilities before and after implementing regular security updates and audits. There is a significant reduction in vulnerabilities post-updates, if we see, highlighting the effectiveness of these practices in enhancing the overall security posture of an organization. Proactive measures coupled with real-world insights can significantly reduce breach times. Let's explore some proactive measures and case studies. Proactive security measures have often proven effective in various real-world scenarios. These measures include regular vulnerability assessments, penetration testing, security audits. These help organizations identify and address weaknesses before they can be exploited. Additionally, implementing security automation and orchestration tools allow for faster response times and reduces the risk of human error. One of the key benefits of proactive security measures is the reduction in breach detection and response times. Let's dive deeper into the importance of reducing breach times and the strategies involved. Reducing the time it takes to detect and respond to security breaches is critical. This can be achieved through rapid detection using advanced threat detection techniques, continuous monitoring, and automated response mechanisms such as security orchestration, automation, and response tools. Integrating security tools and platforms streamlines the incident response, and developing incident response playbooks ensures swift and effective responses. To illustrate the impact, let's look at how proactive security measures can significantly reduce breach detection and response times. This line graph shows how breach detection and response times decrease over a year after implementing proactive security measures. Both detection and response times show a significant reduction, underscoring the importance of continuous monitoring and automation in maintaining a secure cloud environment. Now let's take a look at some specific security tools, starting with threat intelligence platforms. Intelligence platform, or in short TIP, is designed to help organizations aggregate, analyze, and act upon threat data to improve their security posture. Firstly, TIPS gather data from multiple sources. This source includes open source feeds, commercial vendors, and internal threat intelligence. By pulling data from various data streams, TIPS provide a comprehensive view of potential threats. Next, the platform processes the aggregated data. Through advanced analysis, TIPS identify potential threats, turning raw data into actionable insights for security teams. Now let's discuss how TIPS can actively prevent breaches. TIPS collect data from various sources, including, like I said, open source feeds, commercial threat intelligence providers, internal security logs, and much more. This step ensures that the platform has a wide and detailed view of the threat landscape. Next, we have threat analysis. Using advanced algorithms, machine learning, and correlation engines, TIPS analyze this data to identify patterns and potential threats. This capability allows TIPS to detect that might indicate malicious activities. Finally, TIPS generate actionable intelligence that can be used to update security policies, configure intrusion detection systems, and automate responses to detected threats. This process enables organizations to respond swiftly and effectively to potential threats. By integrating TIPS into your security infrastructure, you enhance your ability to detect, analyze, and respond to threats in real time, providing a significant boost to your overall security posture. Now, let's look at some of the key benefits of threat intelligence platform. TIPS centralize threat data and apply sophisticated analysis techniques, which significantly improves both the accuracy and speed of threat detection. This capability is crucial for identifying potential threats before they can cause harm. TIPS empower organizations to stay ahead of emerging threats by continuously monitoring and analyzing global threat landscapes. This proactive approach helps you anticipate and mitigate attacks before they happen. Insights provided by TIPS are enable quicker, more informed responses to security incidents. By reducing response times, TIPS help minimize the damage caused by breaches, protecting your organization's critical assets. In summary, TIPS play a vital role in modern cybersecurity strategies, enhancing threat detection, enabling proactive defense, and streamlining incident response. This diagram visually represents the flow and integration of a threat intelligence platform within a security framework. We have threat intelligence platform, which has aggregation of data. And then using aggregation data, we have data analysis and actionable intelligence generated by the TIP. This integration ensures a dynamic and responsive security framework, where each component works in concert to protecting your organizations from a wide array of threats. Now let's dive into intrusion detection system. And IDS, in short, monitors network traffic from suspicious activity and potential threats. This helps in alerting security teams to any anomalies that could indicate a security breach. IDS can be classified into two types, one being network-based IDS and the other being host-based IDS. Network-based IDS monitors network traffic across the entire infrastructure, detecting threats that move through the network. Host-based IDS focuses on individual devices, monitoring for suspicious activity at the endpoint level, making it ideal for detecting insider threats or attacks on specific assets. Both network and host-based IDS are critical components in identifying and mitigating threats within a cloud environment. Detection systems utilize different detection methods, which help in identifying potential threats. We have signature-based detection. This method compares network traffic against a database of known threat signatures. It's effective for detecting known threats but may miss the previously unidentified attacks. We have next anomaly-based detection. This approach uses machine learning and statistic models to detect deviations from normal network behavior. It's more adept at identifying new or unknown threats. that can generate more false positives. In terms of response capabilities, passive IDS is a type of IDS which allows the security team but doesn't take action against a detected threat, leaving the response to human intervention. We have next active IDS, also known as intrusion prevention system. These systems can automatically block or mitigate detected threats, providing real-time protection. IDS solutions can integrate with threat intelligence platforms for enriched threat data and automated response mechanisms, enhancing their overall effectiveness. They are also compatible with other security platforms like firewalls, security information, and event management systems, ensuring comprehensive protection. Finally, when considering IDS implementation, it's important to evaluate their performance impact. This includes ensuring that they can handle high volumes of network traffic without introducing significant latency, which is critical for maintaining operational efficiency. This slide presents a comparison table of different intrusion detection systems based on their detection methods, response capabilities, and integration options. We have three solutions here which you can compare. One being signature-based detection. This method relies on comparing network traffic against a database of known threat signatures, which is effective for identifying well-known threats. However, it may miss novel attacks. This offers a passive IDS approach, meaning it allows the security team to suspect activities but takes no automated action. It integrates with tips and firewalls, providing a basic layer of protection. We have an IDS B, for an example, which employs anomaly-based detection, which uses machine learning and sophisticated statistical models to detect deviations from normal network behavior. This method is more adept and can identify new or unknown threats, but can generate more false positives. IDS B is an active IDS capable of automatically responding to threats by blocking or mitigating them in real time. It integrates with SIEMs and tips, making it ideal for more dynamic and complex environments. We have next IDS C. This solution offers hybrid detection method that combines both signature and anomaly-based approaches, providing a balanced and a comprehensive detection mechanism. Like IDS B, IDS C is also an active IDS with automated response capabilities. It offers the broadest integration options, working seamlessly with tips, SIEMs, and firewalls. So we have a holistic security framework. Understanding these differences can help you choose the right IDS solution that best fits your organization's specific needs and security posture. Now let's visualize how these IDS tools fit into broader security infrastructure. We have this diagram which illustrates how IDS integrate with a broader security infrastructure, including threat intelligence platform and security information and event management systems. At the core of this diagram, we have IDS, which plays a central role in monitoring network traffic and identifying potential threats. It feeds information to tips, which enhance threat detection by aggregating and analyzing data from multiple sources. Tip then processes this information, generates actionable intelligence that can be fed back to the IDS for real-time threat prevention. Then we have SIM systems, which are also integrated into this ecosystem, serving as a hub for collecting, analyzing, and storing log data from various sources, including IDS and tips. This diagram also shows security organization, orchestration, and automation response tools, which can be integrated, further automating the incident response processes by triggering predefined actions based on insights provided by tips and SIM systems. This holistic approach to security ensures that your organization has multiple layers of defense, with each component reinforcing the others to create a robust and dynamic security posture. Next, we'll explore some real-world case studies that demonstrates the effectiveness of these integrated security solutions. Firstly, we talk about Capital One data breach. In 2019, Capital One experienced a major data breach that exposed the security, like sensitive personal information of over 100 million customers. This breach was caused by a misconfigured firewall on a cloud-based storage system, which allows unauthorized access. The security gap was the attack exploited weak access controls and a misconfigured web application firewall. The attacker used a vulnerability in this infrastructure to gain access to sensitive data stored in Amazon S3 buckets. This breach resulted in a significant financial loss for Capital One, including an $80 million fine by the Office of the Controller of the Currency, which is OCC. It also damaged the company's reputation and trust with customers. This emphasized the importance of properly configuring cloud security settings, regularly auditing and updating security configurations, also employing stronger access control to protect sensitive data. Another notable case is Netflix's approach to security automation and orchestration. Netflix, as a leading streaming service provider, operates entirely on cloud, using AWS to manage its infrastructure as well. Given its massive scale, Netflix faced potential threats from large-scale cyber attacks, including DDoS attacks, insider threats, and data breaches. To counter these threats, Netflix implemented a multi-layered security strategy that includes advanced threat detection systems, continuous monitoring, and the development of internal security tools such as SecurityMonkey and Lemur to automate security processes. Netflix also adopted a chaos engineering approach, regularly simulating failures and security breaches to test the robustness of its systems. Netflix's proactive approach has significantly reduced security incidents, enhancing its ability to quickly detect and respond to threats. And it also improved its overall security posture. Similarly, Sony PlayStation Network breach offers some important lessons as well. So let's talk about that. It was a while back. In 2011, Sony's PlayStation Network was hacked, which led to a theft of personal information from 77 million user accounts, including credit card details as well. The attack was facilitated by inadequate security measures, including outdated software and insufficient encryption of sensitive data. The breach forced Sony to shut down the PSN for 23 days, resulting in a significant loss of revenue. Sony also faced numerous lawsuits and had to invest heavily in improving its security infrastructure. This case underscores the need for regularly updating software, encrypting sensitive data, and implementing strong incident response protocols to mitigate the effects of a data breach. Dropbox's multi-layered security approach provides another instructive example as well. So let's talk about that. Dropbox is a cloud-based file storage service used by millions of users worldwide, including enterprises that store sensitive data. As a cloud service provider, Dropbox faced threats from data breaches, unauthorized access, and data leaks, which could compromise the privacy of its users. So Dropbox adopted a multi-layered security approach as well, including two-factor authentication, encryption of data at rest, and in transit as well, regular security audits. Dropbox also engages in regular penetration testing and has a robust bug bounty program to identify vulnerabilities as well. Security strategy. Dropbox maintains a strong security record with minimal incidents of data breaches. The proactive measures taken by Dropbox have significantly enhanced its operation as a secure cloud storage provider as well. Looking ahead, what are the emerging threats in cloud security? So let's explore some of the future trends as well. Computing continues to evolve. Does the threats and challenges associated with it? Let's explore some of the emerging threats that organizations need to be aware of. Firstly, container security issues. Containers, while efficient, can introduce vulnerabilities if not properly secured, especially when using shared resources. This can lead to privilege escalation or container escapes, where an attacker breaks out of a container to gain access to other host systems. You have serverless architecture vulnerabilities. Serverless environments reduce the attack surface but can still be vulnerable to issues like insecure configurations, mismanaged permissions, etc. You have supply chain attacks. As organizations rely more on third-party vendors, supply chain attacks where attackers compromise the security provided to infiltrate their customers are becoming more common. So some of the strategies for mitigating some of these threats, right? If we talk about that, we have adopting zero trust architecture, which means implementing a zero trust model where no entity inside or outside of the network is trusted by default. Continuously verifying users and devices before granting access, ensuring that even those within the network are monitored and authenticated regularly. We have regular security audits, basically conducting frequent security audits to identify and address vulnerabilities. Then we have vendor risk management, which strengthens supply chain security by carefully vetting vendors, requiring them to adhere to security standards, etc. Let's look at the future trends as well in cloud security that are shaping up. As we look into the future, cloud security will increasingly rely on advanced technologies to protect against evolving threats. Two key trends are at forefront, which are AI-driven threat detection and quantum-resistant encryption. AI-driven or like artificial intelligence and machine learning-driven are becoming integral to detect threat detection systems. These technologies can identify vast amounts of data at very incredible speeds, enabling us to detect anomalies and potential threats that might be missed by traditional security measures. We have quantum-resistant encryption, which is being developed to protect data against potential future threats posed by quantum computing. Quantum computers could potentially break traditional encryption methods such as RSA and ECC by solving complex mathematical problems exponentially faster than classic computers. To counter this threat, new encryption algorithms are being developed. Together, these environments represent the cutting edge of cloud security, providing robust defenses against both current and future threats. Organizations that adopt these technologies will be better equipped to protect their data in an increasingly complex and dangerous cyber landscape. Let's look at this encryption, with quantum-resistant encryption and why it's and AI-driven encryption, and why it's crucial for the future as well. Quantum computing poses a significant threat through encryption methods, as we rely on vulnerability of current encryption and quantum-resistant algorithms. Quantum computers have the potential to break widely used encryption methods because they solve mathematical problems exponentially faster than classical computers. This capability would render many of our current encryption techniques ineffective, exposing sensitive data to potential breaches. To counter this threat, new encryption algorithms are being developed that are resistant to quantum attacks as well. As we prepare for the advent of quantum computing, organizations must begin assessing their current encryption methods and planning for the transition to quantum-resistant encryption as well. How do we prepare for these, right? Organizations should assess their current encryption methods, like I said, and then also transition planning. Begin planning for the transition to quantum-resistant encryption techniques, including new algorithms and updating key management practices. And also organizations need to stay informed on what encryption techniques are being built and the necessity of adopting them as well. In summary, let's review the key points we have covered today and look at how organizations can stay ahead to mitigate any emerging and existing threats. In summary, we have explored the critical aspects of cloud computing security, including the importance of multi-layer protection strategy and the role of advanced threat detection. By understanding the various layers of protection and employing cutting-edge technologies to detect and mitigate threats, organizations can significantly enhance their cloud security posture. As cloud computing continues to evolve, staying informed about future trends, and adapting security strategies will be key to maintaining robust cloud security. The integration of AI-driven threat detection systems and adoption of quantum resistant encryption are just two examples of how the industry is preparing for the future. By being proactive and forward-thinking, organizations can protect their data and maintain the trust of their customers. Finally, thank you for the opportunity, and I hope you find the information valuable. Thank you again.